We're on Unit 8, Lesson 6. We're still talking about circles, but now we're going to talk about segment lengths in circles. So our first theorem talks about if the segment intersects inside of the circle, then A times B equals C times D. So let's look at some examples. Our first example, here's our circle, and ST is the length is 3 and 6. And then segment QP, the length is 9 and X. And let's go back and look at our theorem. Our theorem says that if two segments intersect inside the circle, then you're going to multiply A times B equals C times D. So that means we're going to multiply 3 times 6 is going to equal to 9 times X. So that's how I set it up. 9 times X is equal to 3 times 6. So 9x is equal to 18. I divide by 9 and our x is equal to 2. Example 2, again our segments are intersecting inside of our circle. So I set it up as 18 times x is equal to 12 times 9. I multiplied 12 times 9 and I got 108, which is equal to 18x. I divided by 18 and I got x was equal to 6. My third example, I have 6 times x plus 3 is equal to 4 times 2x minus 3. So I went ahead and I distributed and I got 6x plus 18 is equal to 8x minus 12. I combined like terms, so minus 6x, and I got 18 is equal to 2x minus 12. I added 12 to both sides and I got 30 is equal to 2x. I divided by 2 and I got x was equal to 15. Then finally, example 4, again, the lines are intersecting inside the circle, so I'm going to multiply 3x times x and 9 times 3. So 3x times x gives me 3x squared, and that equals 9 times 3, which is 27. I divide by 3, and I get x squared is equal to 9, because 27 divided by 3 is 9. And then to get rid of my x squared, I need to take the square root. So I square rooted both sides and I got x was equal to 3. Okay, let's look at our second theorem. Our second theorem is talking about when segments intersect outside of the circle. So previously we were talking about when segments intersect inside the circle. Now we're talking about when they intersect outside the circle. Something you need to understand is that when you're talking about segments that intersect outside of a circle, you're going to multiply the outside segment, the external part of the segment, times the entire segment. So that means that we're going to multiply B times C is times A times C. So not just B times C is equal to B and A. We're actually going to do BC, which is our external, times our entire length, which is AC. And that's going to equal D times C times our entire length, which is E times C. So let's go ahead and look at some examples. Now our first example, I've got segment RQ and segment RT. Now we first have to look at the external. So RP is our external, which is 9, and we're going to multiply that by our entire length, which is RQ. So that's 9 plus 11. So 9 times 9 plus 11. And then our second segment is 10, that's our external. So 10 times our entire segment, which is 10 plus x. So 10 times 10 plus x. So I added the inside, which was 20. So 9 times 20 is equal to, I went ahead and I distributed. So I got 100, because 10 times 10 is 100, plus 10x. So 9 times 20 is 180, is equal to 100 plus 10x. I subtracted 100 from both sides, and I got 80 is equal to 10x. I divided by 10, and I got x was equal to 8. Now let's look at example 2 over here. Again, we have to do external times our entire length is equal to external times our entire length. So let's look at our first segment. My external is 11. So 11 times 11 plus 10, because that's our entire length. So 11 times 10 plus 11 equals 12 times 12 plus x. So 12 times 12 plus x. So I went ahead and I added my parentheses. So 11 times 21 is equal to 12 times 12 is 144, and 12 times x is 12x. So 11 times 21 is 231. I subtracted 144 from both sides, and I got 87 is equal to 12x. I divided by 12, and my x is equal to 87 divided by 12. Okay? Now let's go ahead and look at our second theorem. Our second theorem is still dealing with segments that intersect on the outside of my circle. But if you notice, in the second theorem, my second segment piece here, DC, doesn't extend all the way to the inside of my circle. So I'm still going to have BC, which is my outside, times my entire length, which is AC, and that's going to equal CD squared. So let's go ahead and look at some examples. So I have 8 times 8 plus 2x equals to 20 squared. Okay, because our segment doesn't continue inside of our circle. So we're actually going to take 20 squared. So 8 times 8 is 64, plus 8 times 2 is 16x is equal to 20 squared is 400. I subtracted 64 from both sides, and I got 16x is equal to 336. I divided 16 from both sides, and I got x was equal to 21. And our second example here, we've got 5, which is our external, times our entire length, which is 5 plus x. So I have 5 times 5 plus x. And then here, DC, we have 10 squared because our segment doesn't go through our entire circle. So we have 10 squared. So 5 times 5 is 25, and 5 times x is 5x is equal to 10 squared is 100. I subtracted 25 from those sides, and I got 75 is 5x. I divided by 5, and I got x was equal to 15.